10 prehistoric disasters that erased entire civilizations overnight. Number 10. The Zanclean Flood. Somewhere around 5,330,000 years ago, the entire Mediterranean Sea filled back up in what may have been less time than it takes a single human generation to grow old. For roughly 600,000 years before that moment, the Mediterranean basin had not been a sea at all. Cut off from the Atlantic by tectonic movement at the Strait of Gibraltar, it evaporated again and again into a chain of salt flats and hypersaline lakes sitting more than 3 kilometers below the level of the world ocean outside. A basin the size of a subcontinent, essentially empty. Geologists call this the Messinian salinity crisis. The name is dry. The reality was a dead sea the size of a dozen countries, baking under its own accumulated salt. In 2009, geophysicist Daniel Garcia Castellanos and colleagues at the Spanish National Research Council published findings in Nature that reconstructed what happened when the Atlantic finally broke through. Using the buried channel structure still preserved under the modern strait, a canyon over 200 kilometers long with sections eroded more than 250 meters deep, their model calculated a peak discharge on the order of 100 million cubic meters of water per second. For comparison, that is roughly 1,000 times the average discharge of the Amazon River, the largest river system on Earth by volume, sustained not for a moment, but for months. Later analysis of borehole and seismic data suggested that as much as 90% of the water needed to refill the entire Mediterranean basin moved through that channel in a period of only a few months to 2 years. At the peak of the flood, models suggest sea level in the basin may have risen by more than 10 meters in a single day. There is no pivot phrase big enough for that number, so consider it plainly instead. A body of water large enough to separate 3 continents went from a scorched, salt-crusted wasteland to a functioning sea within a span of time shorter than a single olive tree takes to bear its first fruit. Nothing that could be called civilization existed to record it. The ancestors of the human lineage were, at most, only just beginning to walk upright on the African savanna, thousands of kilometers from Gibraltar, and would not develop anything resembling a settled society for another 5 million years. The Zanclean flood is not a story about a civilization erased. It is something colder than that. Proof that the planet is capable of producing the single most violent flood event in its geological history, and doing it in a canyon nobody was alive to see, on a schedule that owed nothing to any witness at all. What the flood left behind is written only in rock, the buried channel itself identified beneath the strait, and, scattered across the Mediterranean floor, a jumble of angular, unweathered breccia, debris that fell too fast and too violently to be shaped by anything except catastrophic transport. Independent land-based evidence published in Nature's Communications Earth and Environment in 2024 has since traced matching erosional channels on Sicily, tracking the flood's path from the other direction. If a sea can refill this fast with nobody watching, consider what happens when the ground instead comes apart underneath people who were watching and arguing about exactly when it happened for the next 2,000 years. That argument starts with a volcano in Iceland. Number 9. The Hekla 3 eruption. Ask 3 different research teams when the Hekla 3 eruption happened, and there is a real chance you will get 3 different centuries. Hekla, in southern Iceland, is one of the most active and least predictable volcanoes on Earth. And sometime during the Bronze Age, it produced the most severe eruption of its entire Holocene history. The trouble is pinning down exactly when. Radiocarbon dates on the Hekla 3 tephra layer, the sheet of volcanic ash and rock that spread across the North Atlantic and now serves geologists as a buried timestamp, cluster around several different windows. Some studies place the eruption near 1021 years before the Common Era, others closer to 929, and a minority reading connecting Icelandic tephra to Egyptian records has argued for a date as early as 1159 years before the Common Era, close enough to a documented famine under Ramesses III that some have proposed a direct link. What is not disputed is the scale. Hekla 3 threw an estimated 7.3 cubic kilometers of rock and ash into the atmosphere. A volcanic explosivity index of 5. Powerful enough to blanket Scandinavia, the British Isles, and parts of continental Europe in a fine gray layer that still shows up in peat bogs and lake sediments a continent away. Ice core and tree ring evidence tied to eruptions in this window point to northern hemisphere cooling that appears to have persisted for as long as 18 years afterward. But here's where the tidy chronology falls apart, and where the eruption becomes more than a footnote in volcanic history. Somewhere in the centuries surrounding Hekla 3, the interconnected Bronze Age world, from the Aegean through Anatolia into the Near East, underwent a cascading systems collapse that historians still argue about today. Cities burned, trade networks severed, entire writing systems abandoned for generations. Hekla 3 is not the only proposed trigger, and it would be dishonest to call it the trigger. Drought, invasion, earthquake swarms, and internal political failure all appear in the same stretch of centuries. What the tephra layer proves is narrower, and in its way more unsettling. Whichever combination of forces broke the Bronze Age world, an Icelandic volcano thousands of kilometers from any of the affected capitals, was adding its own weight to the scale, cooling harvests it never touched and never announced itself for doing it. Hekla has not gone anywhere. Its most recent eruption began on the 26th of February in the year 2000, preceded by only around 79 minutes of detectable tremor, among the shortest warning periods recorded for any major eruption on Earth. The Icelandic Meteorological Office monitors it continuously today, using ground deformation sensors and gas detectors, and current measurements suggest its shallow magma chambers have been steadily refilling since that last eruption. Volcanologists now describe Hekla, plainly, as overdue. The uncertainty over Hekla 3's exact date is not a failure of the evidence. It is what happens when a single eruption's fingerprints get smeared across too many archives and too many centuries. It is nothing, though, compared to the certainty problem waiting in the next entry, where the argument is no longer about when a volcano erupted, but about who exactly it left alive. Number 8. The Kikai-Akahoya eruption. In 2024, the journal Antiquity awarded its Ben Cullen Prize to a research team that had spent years reconstructing something almost nobody thought was recoverable. A step-by-step account of how human communities came back from one of the largest volcanic eruptions of the last 10,000 years. Approximately 7,300 years ago, the submarine Kikai caldera, south of Japan's Kyushu Island, produced the Akahoya eruption, a volcanic explosivity index 7 event that ejected an estimated 330 to 460 cubic kilometers of volcanic material. Pyroclastic flows, fast-moving currents of superheated gas and ash capable of outrunning any animal on foot, swept across the nearest islands. Ashfall was heavy enough to be identified in sediment cores more than 800 kilometers away in Japan's Tokai region, where it shows up as a sudden shrinkage in shellfish size and a measurable drop in the number of settlements, grinding stones, and arrowheads left behind. For decades, the standard account of what happened next was simple almost to the point of being satisfying. The eruption wiped the southern Jomon culture off the map, and the region sat empty for centuries until new populations moved back in from elsewhere. Junzo Uchiyama and Mitsuhiro Kuwahata of Kyushu University, whose prize-winning study focused on the nearby island of Tanegashima, found something messier and, in its way, more disturbing than total annihilation. On Tanegashima itself, Akahoya annihilated the local Jomon population, the researchers' own word, gone from the archaeological record entirely, with no trace of continuous habitation for generations. But communities on other islands within the same ashfall zone survived. Not thriving, not untouched, surviving. Adjusting their diet, shifting their toolkits, and eventually, once enough time had passed for the land to recover, moving back into the emptied zones themselves and rebuilding. What the excavation actually revealed, in other words, was not a clean boundary between the living and the erased. It was a patchwork, decided island by island, sometimes bay by factors that had nothing to do with how close anyone stood to the caldera, and everything to do with the accident of which slope the ash column happened to fall across that week. Not annihilated everywhere, not spared everywhere. Somewhere in between. And the in-between is where the harder question sits. What actually decides which community gets to come back, and which one simply stops appearing in the ground? The Kikai caldera has not finished with its own story. Recent seafloor surveys have detected a large, dome-shaped mass of magma resurging beneath the caldera floor. Evidence, researchers say, that the system has been quietly rebuilding a fresh reservoir in the 10,000 years since Akahoya. Nobody is forecasting an imminent repeat, but the caldera that produced one of the largest eruptions of the last 100,000 years is not extinct. It is refilling. The Jomon survivors of Akahoya rebuilt without knowing whether the mountain south of them was finished. The next entry concerns a mountain in Europe that gave its neighbors almost as little warning and considerably less room to adapt. Number 7. The Laacher See eruption. Along the rivers of what is now western Germany, roughly 13,000 years ago, late glacial hunter-gatherer groups of the Federmesser technocomplex had spent generations building something easy to overlook in the archaeological record: relationships. Long-distance exchange networks moved flint, ornaments, and marriage partners across hundreds of kilometers, stitching small, mobile bands into a much larger social fabric that let any single group survive a bad season by leaning on its neighbors. Then the ground beneath the Eifel region tore open. The Laacher See eruption, dated through dendrochronological refinement to approximately 12,900 years before present, was a caldera-forming event large enough to send pyroclastic density currents, fast-moving avalanches of ash, gas, and rock fragments, through the surrounding valleys, and to loft an ash column that deposited a distinct, chemically identifiable layer of tephra across a belt of Europe stretching from the Alps to the Baltic. That layer, the Laacher See tephra, is now one of the single most important dating markers in the entire European late glacial record. A buried instant, chemically unique, that lets archaeologists line up sites hundreds of kilometers apart on the same calendar day. Felix Rita, an archaeologist at Aarhus University who has spent more than a decade studying the eruption's aftermath, has argued that the damage went well beyond the ash itself. Applying social network analysis to the archaeological record, Rita has shown that the eruption's most lasting wound was not physical. It was relational. Communities in the immediate ashfall zone were forced to abandon territory outright. But groups on the network's edges, including hunter-gatherers occupying the far northern periphery of the human range in what is now southern Scandinavia, found themselves cut off as the exchange routes running through the devastated center simply stopped functioning. What makes this particularly haunting is that isolation, unlike a pyroclastic flow, does not show up as a burn layer. It shows up decades later in toolkits that stop matching their neighbors, in raw materials that stop arriving from 300 kilometers away, in a regional culture, archaeologists call it the brome culture, that grew increasingly self-contained not because its people chose solitude, but because the web holding them to everyone else had been quietly and permanently cut. Not every consequence was bleak. Rita's research also documents a kind of forced innovation in the aftermath. Without their old trade partners, some communities developed new tool-making traditions and territorial strategies of their own, a grim creativity born directly out of the eruption's isolation. The eruption's cruelty did not necessarily end when the ashfall stopped. One hypothesis still being tested holds that fluoride compounds released alongside the tephra may have poisoned grazing animals, and in turn, the human foragers who depended on them. A slower chemical postscript working through the food chain in the seasons after the sky cleared, arriving long after anyone still standing would have believed the danger had passed. The Eifel volcanic field that produced Laacher See has never gone fully silent. Carbon dioxide continues to seep from the ground around the lake today, monitored by German geological authorities as a sign of a magma system still cooling, slowly, beneath one of the most densely populated regions of Europe. The late glacial world thought distance was a form of safety. The next entry belonged to a landscape that assumed solid basalt was a form of permanence, and lost that argument in a matter of days. Number 6. The Missoula floods. In 1923, a geologist named J. Harlan Bretz, then at the University of Chicago, walked across eastern Washington state and described a landscape that made no sense under the rules his own discipline insisted on. Coulees carved to bedrock, giant ripple marks the height of houses, dry waterfalls 10 times the width of Niagara, stranded miles from any river big enough to have cut them. Bretz proposed, in print, that the region, which he named the Channeled Scablands, had been carved not gradually by ordinary rivers over millions of years, but catastrophically by a flood of almost unimaginable size in a geological instant. The response from the geological establishment was not skepticism. It was closer to ridicule. 1920s geology was built on uniformitarianism, the working assumption that the present is the key to the past, that landscapes form the way they are still forming today, slowly, without dramatic interruption. A flood big enough to do what Bretz described would have required a violation of that principle so large that most of his colleagues simply refused to entertain it. In 1927, he was invited to defend his theory before the Geological Society of Washington, D.C., where 6 senior geologists had prepared formal papers arguing against him, a lineup Bretz privately dismissed as the challenging elders. He held his position anyway. It took another geologist, Joseph Pardee, to eventually supply the missing piece: the ice-dammed remains of a colossal Pleistocene lake in western Montana, Glacial Lake Missoula, whose shoreline terraces are still visible today, wrapped around the hills above the modern city like a bathtub ring. When the ice dam holding back the lake failed, and research now suggests it failed not once but repeatedly, dozens of times, as the retreating ice sheet re-dammed and re-released the basin over the course of a few thousand years, the result was exactly the flood Bretz had described. The numbers, once modeled, justified every part of his original claim. Peak discharge from the largest floods has been estimated at somewhere between 10 and 20 million cubic meters per second. Expressed another way, on the order of 10 to 20 cubic kilometers of water an hour, or roughly 50 to 100 times the average discharge of the Amazon River. Floodwaters have been reconstructed moving at speeds approaching 100 kilometers an hour, carving the scablands not over eons, but within a span of days. Not a valley, not a river course shaped patiently across an age. A wound, cut in an afternoon, then cut again, and again, for thousands of years, by the same lake refilling and failing on a loop nobody was tracking. It was not until 1979, more than 50 years after his ridiculed presentation, that Bretz, then 96 years old, was awarded the Geological Society of America's Penrose Medal, the field's highest honor, in what amounted to a formal admission that catastrophe, not gradualism, had written that landscape. Told of the honor, Bretz is said to have remarked to his son, "All my enemies are dead, so I have no one to gloat over." It is one of the driest punchlines in the history of earth science, and one of the truest. The mechanism that carved the scablands has not vanished from the modern world. It has only changed address. Ice-dammed and moraine-dammed lakes still exist across the Himalaya, the Andes, and Alaska, and they still fail without warning. In October of 2023, a glacial lake collapse in Sikkim, India, released an estimated 50 million cubic meters of water in a matter of hours, killing at least 24 people and leaving more than 70 missing. Different mountains, same physics. The geological establishment eventually admitted it had underestimated how fast a landscape could change. The next entry concerns a slope that gave no such warning at all. No decades of academic argument, just an ocean floor that gave way in an afternoon. Number 5. The Storegga Slide. Off the coast of Norway, a section of continental shelf roughly the size of Scotland let go of the seafloor and slid into the deep basin of the Norwegian Sea. Researchers including Stein Bondevik, who has spent decades mapping the tsunami deposits this event left along the Norwegian coastline, placed the slide at approximately 8,150 years ago, close to 6,160 years before the Common Era. Bondevik's foundational study of the wave's age and run-up, built from sand and shell layers dug out of Norwegian lake basins far above normal high tide, remains the reference every later reconstruction is measured against. The volume involved is difficult to hold in the mind at all, somewhere between 2,400 and 3,200 cubic kilometers of sediment, a slab hundreds of meters thick spread across an area of roughly 95,000 square kilometers, larger than Portugal, failing and moving within minutes. The resulting tsunami reached estimated run-up heights of 20 to 25 meters along the Norwegian coast. Sand layers deposited by the wave have been traced as far away as eastern Scotland and, more recently, into the southern North Sea itself. For a long time, the standard account of Storegga treated the tsunami as the final blow against Doggerland, the low-lying landmass that had once connected Britain to continental Europe, and, by then, had been reduced by thousands of years of rising post-glacial seas to a shrinking archipelago. In this telling, Mesolithic communities clinging to Doggerland's last high ground had nowhere left to run when the wave arrived. What the new evidence undercuts is not the wave. It is the ending everyone assumed it wrote. In 2020, James Walker and colleagues associated with the University of Bradford's long-running Doggerland research program published findings in the journal Antiquity, presenting the first direct evidence of Storegga tsunami deposits from the southern North Sea itself. Alongside sediment-preserved ancient DNA showing signs of vegetation recovery after the floodwaters withdrew, the study argued that the wave's role may have been overstated, that much of Doggerland had likely already drowned gradually under rising seas before Storegga ever struck. The debate has not settled the matter, and it should not pretend to. The mainstream position still treats Storegga as a major, abrupt blow to whatever Mesolithic population remained on Doggerland's last fragments. A competing view holds that the tsunami's role has been dramatized past what the sediment can support. What is not disputed by anyone publishing on either side is the wave itself, a wall of water crossing open sea toward a coastline with no seismic warning, no felt tremor, nothing but a section of seafloor that gave way in silence and reached the shore as a catastrophe minutes later. The submarine slopes of the Norwegian continental margin have not stopped accumulating sediment. Geological surveys continue to monitor the same slope systems today because the underlying question was never whether another slide could happen, it is only when. The coastlines of the North Sea now support tens of millions of people in cities that did not exist when Storegga last let go. Whether Storegga delivered a final blow or arrived after the ending had mostly already been written, it still crossed an ocean floor in minutes and a coastline in hours. Not every entry on this list required that kind of speed underwater. The next one needed the ground itself to remember its own shape, and then, without warning, forget it. Number 4. Mount Mazama. The Klamath people of southern Oregon tell a story about a battle between Lau, chief of the world below the mountain, and Skell, chief of the world above the sky. Lau, spurned by a chief's daughter, retreated in fury beneath his mountain and hurled fire and rock at Skell, who answered from the summit of a neighboring peak known today as Mount Shasta. The fighting darkened the sky. Ash fell like snow. When it ended, Lau's mountain had collapsed in on itself, and the hole where it had stood slowly filled with water. That mountain is Mount Mazama. The hole is Crater Lake. Approximately 7,700 years ago, according to the United States Geological Survey, Mount Mazama produced the largest eruption in North America in more than 500,000 years, a climactic event that emptied its magma chamber of an estimated 50 cubic kilometers of material, roughly 50 times the volume ejected by the 1980 eruption of Mount St. Helens, and sent an eruption column towering an estimated 50 kilometers into the sky. With its internal support gone, the summit, once standing more than 3,700 meters tall, collapsed into the emptied chamber beneath it, swallowing itself in a matter of hours and leaving a caldera nearly 10 kilometers across. Archaeologists have recovered physical proof that people had deep roots in this landscape long before the mountain came down. At Fort Rock Cave in central Oregon, excavator Luther Cressman recovered dozens of sagebrush-bark sandals in 1938, later radiocarbon dated to somewhere between roughly 10,200 and 9,300 years old, among the oldest directly dated footwear on Earth. Mazama's ash fell directly on top of those sandal-bearing layers, sealing them beneath a fine gray cap that marks, without ambiguity, the last living surface before the sky went wrong. People were not passing through this landscape. They had been standing on it for 3,000 years before it changed underneath them. Geologists studying oral tradition rarely get a case this clean. A story survived, unbroken, across roughly 300 human generations, carried by voice alone, until researchers holding rock samples could confirm that two fighting gods were, underneath the metaphor, a structurally accurate account of a stratovolcano's climactic collapse. An explosive emptying, followed by centuries of the resulting caldera slowly filling with water. Oral tradition is not usually treated as evidence in earth science. It survives being edited, exaggerated, moralized, and adapted to whatever the listening generation needs it to mean. The Klamath account should, by most working assumptions about how stories degrade, have long since lost its geological shape. It did not. Researchers studying indigenous oral traditions of the Pacific Northwest have repeatedly flagged the Mazama legend as one of the strongest candidates anywhere in the world for genuine, deep-time geological memory. That raises an uncomfortable question about every other flood myth and fire legend this species has quietly filed under folklore. The Cascade volcanic arc that produced Mazama has not gone extinct. Several of its neighboring peaks remain active and monitored today. But nothing else on this list offers a survivor's voice, handed forward with enough fidelity to still mean something 8,000 years later. The next entry does not have a legend attached to it. It has an ice core, a tree ring, and a date accurate to within 2 years. Proof arriving from an entirely different direction. Number 3. The Ilopango eruption. For most of the last 1,500 years, nobody could say with real precision when the volcano now sitting quietly under a lake outside San Salvador had its worst day. That changed in 2020 when Victoria Smith, head of the Tephrochronology Research Group at the University of Oxford, led a study published in the Proceedings of the National Academy of Sciences that cross-matched 3 independent lines of evidence: sulfate spikes preserved in Greenland ice cores, volcanic shards embedded in those same ice layers, and radiocarbon dating of a tree charred by the eruption itself, to pin the Ilopango eruption to the year 431 of the Common Era, accurate to within roughly 2 years. The eruption they dated, known to volcanologists as the Tierra Blanca Joven event, was immense. Researchers estimate it released more than 50 times the volume of material ejected by the 1980 eruption of Mount St. Helens, with pyroclastic flows carrying roughly 10 times the volume of material that buried Pompeii and Herculaneum at Vesuvius. Thick ash blanketed the Zapatitan Valley and much of what is now central El Salvador, an area that sat directly inside the Maya world's southeastern edge. Excavations at the nearby site of San Andres, buried under the ash, show precisely how fast the transition was. Agricultural fields, structures, and everyday objects sealed in place mid-use, the way Pompeii sealed a Roman street. Furrowed cornfields have been found intact beneath the deposit, rows still visible, crops still in the ground the day the sky turned white. Researchers estimate that the area within roughly 80 kilometers of the volcano was rendered functionally uninhabitable for years, and in the harder-hit zones for decades. Ceramic production across the wider region stopped almost entirely and did not resume at its former scale for an estimated 100 to 150 years. A full human lifetime spent at minimum before the regional economy that depended on it came back. 3 independent proxies agreeing on the same 2-year window matters more than it might first appear. Volcanic eruptions from this deep in the past are notoriously difficult to place on a precise calendar. Most are known only to within a century or more. Ilopango's date is now one of the most tightly constrained eruptions in the ancient world's entire volcanic record. Solid enough that historians studying the broader disruptions across the Maya region in the mid-first millennium finally have a fixed point to measure against, instead of a vague shrug toward sometime in that era. The volcano has not been demoted to history. Ilopango's caldera, now filled by a lake spanning roughly 8 by 11 kilometers, sits at the eastern edge of San Salvador, a capital whose urban core alone is home to more than 1 million people, living beside a volcano proven capable of erupting at a scale that swallows a region for a human generation. Seismic and gas monitoring networks watch it today for exactly that reason. 50 times Mount St. Helens is not a comparison offered for shock value. It is the only way to make a number like 50 cubic kilometers mean anything to a mind built to understand distance, not volume. The next entry needs an even larger comparison, because it involves water moving fast enough and high enough to leave boulders the weight of loaded freight trains stranded 2/3 of a kilometer from the ocean that put them there. Number 2. The Fogo megatsunami. On the island of Santiago, in the Cape Verde archipelago off the coast of West Africa, geologist Ricardo Ramalho, then at the University of Bristol, and his colleagues found boulders that did not belong where they were sitting. Some weighed an estimated 700 tons, roughly the mass of a fully loaded commercial jet. They sat as far as 610 meters inland and nearly 200 meters above sea level, with no landslide, no river, and no plausible local mechanism to explain how they got there. Ramalho's team, publishing in Science Advances in 2015, traced the boulders back to a single source: the catastrophic partial collapse of the nearby volcanic island of Fogo. Helium isotope exposure dating placed the event at approximately 73,000 years ago, give or take roughly 9,000 years either direction. Old enough that no human being anywhere in the Cape Verde Islands existed to see it, since the islands themselves remained uninhabited until Portuguese sailors arrived in the 15th century. The wave itself has been reconstructed at a minimum run-up of 270 meters, taller, measured from base to crest, than most skyscrapers on Earth today. It was generated not by an earthquake or an asteroid, but by something far more mundane in geological terms. One flank of a volcanic island simply gave way and slid in a single catastrophic event into the Atlantic. But the number that should unsettle you is not the wave that already happened. It is the coastline that could, in theory, produce another one. In 2001, researchers Simon Day and Stephen Ward proposed that a similar flank collapse at Cumbre Vieja on the island of La Palma in the Canary Islands could one day trigger a transatlantic megatsunami capable of striking the eastern coastline of the United States. The claim spread widely, resurfacing periodically in documentaries and headlines for 2 decades. The scientific consensus has since moved a considerable distance from that original claim, and it is worth saying so plainly rather than letting the scarier version stand unchallenged. Subsequent modeling indicates that volcanic flank collapses in the Canary Islands most likely occur in multiple, smaller stages rather than one single catastrophic slide, a mechanism far less efficient at generating an ocean-crossing wave. No tsunami deposits matching a transatlantic Cumbre Vieja event have ever been located on either the American or Caribbean coastline, where they would be expected to exist if the original scenario were correct. Leading researchers in Canary Islands geological hazard assessment now describe the single collapse megatsunami scenario as effectively discarded. What remains true, and does not require exaggeration to be frightening enough on its own, is that Cumbre Vieja is an active volcanic system. It last erupted in 2021, over a period of roughly 85 days, consuming close to 3,000 buildings on La Palma itself. The mechanism that carved 70-ton boulders into a hillside on Santiago Island 73,000 years ago has a living relative a few hundred kilometers away, still adding rock to its own flank, one eruption at a time. Fogo's wave crossed open ocean and rewrote a coastline with nobody there to misname it a disaster. The final entry on this list offers the opposite: a disaster with a witness, a date accurate to the day, and an ending that took less time than it will take you to finish this sentence. Number 1. Ozette. Picture a longhouse on the coast of what is now the Olympic Peninsula in Washington state, on an evening in January in the year 1700. Whale oil burns in stone lamps. Cedar bark mats line the walls. A basket sits half-finished beside its weaver. A comb rests near a sleeping mat. A child's cradle waits by the fire. Somewhere out past the surf, a fault line more than 1,000 kilometers long, running the length of the Pacific coast from what is now Northern California to southern British Columbia, is about to fail all at once. The Cascadia subduction zone ruptured on the night of January 26, 1700, in an earthquake now estimated at magnitude 8.7 to 9.2, among the largest earthquakes the region is known to have produced in the last 10,000 years. We know the date with a precision that should be impossible for an event with no written record on this continent. Village registers in Japan, more than 8,000 kilometers across the open Pacific, documented an orphan tsunami that struck their coastline with no local earthquake to explain it. Only cross-referencing those Japanese records against the tree ring and geological evidence of the Pacific Northwest allowed researchers to fix the source and the exact night. On the coast at Ozette, the shaking triggered something that had nothing to do with the ocean at all. A water-saturated hillside above the village, weakened by the tremor, gave way. A wall of mud and debris came down over a cluster of longhouses in what oral tradition, kept alive for centuries by the Makah people, remembers simply as the Great Slide. The slide buried at least 6 longhouses where they stood. It did not burn its contents the way fire does. It did not decay them the way centuries usually do. It sealed them almost instantly in a cold, oxygen-starved, waterlogged clay that halted the ordinary rot of wood, fiber, and food within days of landing. The same chemistry, by coincidence, that has preserved bog bodies and Bronze Age idols elsewhere in the archaeological record. Ozette simply did it to an entire neighborhood on a single night, rather than to a single body over a single season. Archaeologist Richard Doherty of Washington State University, working with Makah community members across 11 years of excavation beginning in 1970, eventually recovered more than 55,000 artifacts from the site. Harpoon shafts, woven baskets, wooden bowls, entire looms, even a wooden carving of a killer whale's dorsal fin inlaid with more than 700 sea otter teeth used in ceremonies tied to whale hunting. The slide had shattered the carving on impact. Decades later, a Washington State University conservator and a Makah student pieced it back together, fragment by fragment. Nothing else had been cleaned out, packed up, or prepared for burial. Everything sat exactly where its owner had set it down, on an ordinary evening that turned out not to be ordinary at all. Consider the implication of what instant actually means here. Not a season of decline. Not a year of drought thinning out a population gradually enough that survivors could adapt, migrate, or simply grow old and be replaced. A slope that had held for centuries, on a night indistinguishable from 1,000 nights before it, failed in the time it takes to stand up from a fire and reach the door. Not every household made it out. Not every object was ever meant to become an artifact. And not one person inside those longhouses had any reason, that evening, to believe the hillside above them was a threat at all. If you have ever stood on a beach anywhere along the Pacific coast of North America, from Northern California to Vancouver Island, you have stood on ground that has done this before. Geological trenching along the same fault has identified at least 19 great earthquakes in the last 10,000 years, an average recurrence of roughly every 500 years. The United States Geological Survey currently estimates a 10 to 15% chance of another full-length rupture on the Cascadia subduction zone within the next 50 years.
and a considerably higher chance, approaching 40% by some estimates, of a serious partial rupture in the southern segment alone. It has now been more than 325 years since the last one. Everything on this list has argued in one form or another that catastrophe moves faster than the world expects it to. A sea refilling in months, a wave crossing an ocean before anyone can name it, a hillside erasing a neighborhood between one heartbeat and the next. Ozette is where that argument stops being abstract, because Ozette comes with a date, a night, and a room where the fire had not yet gone out. It does not ask you to imagine deep time, it asks you to imagine a Tuesday. The ground underneath any settled, permanent, confident human life is not a foundation.
It is alone, and it does not send a notice before calling it in. 10 different mechanisms did the same job. A submarine slope failed in minutes. A caldera swallowed itself in hours. A sea refilled in months, and a hillside let go before anyone could stand up. Across volcanic collapse, tsunami, megaflood, and landslide, the pattern holds steady. The transition from a functioning, inhabited world to an archaeological layer is rarely measured in centuries. It is measured in the time it takes weather to turn, or ground to fail, or water to arrive. The same chemistry keeps recurring in different centuries. In October of 2023, the Sikkim Glacial Lake outburst flood released an estimated 50 million cubic meters of water in hours, killing at least 24 people, a smaller cousin of the Missoula floods. Cumbre Vieja last erupted in 2021, 85 days that consumed close to 3,000 buildings, on the same volcanic system once blamed, incorrectly, for a wave that would cross an ocean. Hekla has stood quiet since 2000, refilling its magma chambers on a schedule nobody can predict with better than a few hours warning. The Cascadia subduction zone, 325 years past its last rupture, sits at up to a 15% chance of repeating Ozette's night within the next 50 years, under coastlines that now hold tens of millions of people instead of a handful of longhouses. What separated survival from erasure across these 10 events was rarely intelligence, and rarely preparation in the way modern institutions define it. On Tanegashima, communities close to Akahoya vanished while others, exposed to the same ashfall, adapted. Around Laacher See, distance from the eruption itself mattered less than whether a group's trade network happened to survive the eruption's disruption intact. At Ozette, the difference between the households that escaped and the ones sealed in clay may have come down to which side of a longhouse someone happened to be sitting on that night. Survival, on this list, looks less like foresight and more like a coin landing a particular way. None of this is an argument for despair, and it is not an argument for false comfort either. It is a description of how the geological and archaeological record actually behaves, once enough of it has been dug up, dated, and cross-checked. Civilizations are not usually worn down. They are interrupted. The only honest response to that pattern is not fear of any single mountain or coastline, but a clearer sense of how thin the membrane has always been between an ordinary evening and the version of it that ends up in the ground. If you want to see more videos like this, click the video on screen now and make sure to subscribe.